I'm Alex Dempsey. I come from the Internet Archive, where for the past 3 years I've managed engineering for ArchiveIt, Arch, Archive Scholar, and many other projects. I'm going to be talking about scaling web archives, the challenges of deduplication, the lightning version with no nuance. Our costs are lowest if we have only one copy of each unique document. If I have 5 million redundant copies of cat.jpg, it's going to cost me more today, tomorrow, and forever. So I want to have just one of these. And I'm on a mission to make it so that you don't have to have, you don't have surprises about how much data you're using, and you can have more unique stuff. Basic web crawler deduplication works like this. You have a URL. You download the document, you compute the document's digest or cryptographic hash, and that digest is much smaller than the document itself, and it's a unique identifier of that document, more or less. And you go, okay, have we seen this digest before? Nope. Then it's not a dupe, so we write a response record in a work file, and that contains the entire payload of the document, all the bytes of what was downloaded. If you have seen this digest before, it is a dupe, and we write a much smaller revisit record in the work, and that record's like 100 bytes instead of the full content of whatever was there before. This all works great until things get bigger and bigger and bigger. One of the first problems that comes up is the dedupe database itself gets bigger and bigger. The digests are small, but when you have 835 billion of them or trillions of them, the maintenance of that database itself is its own project. Archive.org has a layered system for the core Wayback Machine, where it has a smaller Redis database layered over the wider CDX database for serving the Wayback Machine for dedupe, and that's keyed off of the URL and the digest. Archive.org uses a separate digest key database for URL agnostic dedupe, so if the same document lived at 2 different URLs, we could still dedupe between them. Open source databases like Cassandra or Scylla fit the dedupe query pattern very well and can scale out. Uh-oh, too far. Great. Another reason why you might not have an external database for dedupe is if you're using parallel crawlers or mixed technologies. We're using Heritrix, Umbra, Browser, YTDLP for video capture, and I'm sure we'll have more soon. For large-scale collecting, you really need to use a mix of these tools, because maybe you can't capture an entire CCTLD with Browser. But we want to prevent duplicates both within the captures from a given tool and between the tools. We can try to do that ahead of time by scoping things like I'm going to get this with Heritrix and I'll get that with Browser, but that's not going to be perfect. So the better alternative, in my opinion, is to use CDX for dedupe or having a separate dedupe database. Browser-based crawling brings new things. Okay, so what's different about browser-based crawling between Heritrix is the browser's in charge of what web requests are made. And like the JavaScript developer could say, load cat JPEG 500,000 times while crawling the site. You don't want to write a revisit record for each one of those, because even though these digests are very small, at replay time, they can kind of clog up your index and they can impact the replay speed of those websites. So what we are doing now is we're adding a sort of similar to Heritrix, a scene check to skip writing a revisit record more than once in the same crawl. And of course, you can make different calls about how often you want to do that. And since these checks are scoped to active crawls, we can use a simpler in-memory database like Redis. We don't have to have the entire corpus of all time to dedupe against. Many of the crawl surprised in size because of video that was captured. So I think video capture requires its own special handling. They're the largest common media types, and digest-based dedupe can fail with video. We had an example of this where YouTube changed the file, the image sizes that are available and formats available on the same watch page. It's the same video, but because it's been re-encoded, it's a new digest. Now you have a duplicate, a very, very large duplicate. So for that, we have a separate database for all of our video captures with metadata. And we could say, you know what, we've already gotten the video at this watch page. We're not even going to try downloading it again, pre-dupe. And finally, dedupe, scopes, and portability, the revisits that bind. A revisit record is a pointer from one work to another. As soon as you've made that connection, these works must travel together to be replayed. You can try to scope your dedupe to just like a single site, leaving some savings on space on the table, and then you have a portable subcollection. Or you can, think big and dedupe against the whole Wayback Machine, and that'll cost you a lot less, but now you have to serve it from the Wayback Machine and try to extract it later. And finally, there's ripple effects. Once you point to this document, what happens if, for some reason, you need to take that document down? Do you have all the references they're going to track and ripple out and say, OK, we're going to take those down too? I don't know. If you're interested in learning more or hearing some nuance about this, come find me. I'd love to talk about it.